Yeah.
Okay, number 1. So on the test, if you just have a triangle, you have to determine the situation. So we're either looking for any pair, SAS, or triple S. Those are the look fors. So this one is a SAS. So that is cosine law. So have your formula sheet beside you so that you remember which formulas to look for. So I'm finding a side length with cosine law. So which one is it? 1, 2, or 3? First, second, or third formula on my sheet here? This is the middle one, yeah. So I guess I'm just going to call it c squared because it's a side c. C squared equals 5 squared plus 9.3 squared. So fill in okay, making sure the typing situation is good. This one is just type and then do this all times, right? Even the coast, just keep it all going, timesing. And then don't forget to square root answer. Okay, I'll let you work, see if we can all match. And you should be going to 2 decimals. Okay, 12.10, matching. Okay, number 2. We want to get angle B here. So what do we see? So again, I'm looking through my 3 things. Do I have pairs, SAS, or triple S? Find any of those things?
Did you hand this out on Thursday?
Pairs. Nope. I would have handed it out at the very, very, very first day when I gave you the whole package. Did you not find it?
Got it.
Okay, awesome. All right, so there's a pair. So I'm going to go 6.5 across sine 30. And 12 is across from sine B. Okay, once you've set up your pairs, you say times divide, right? So timesing that set, dividing. And what's the situation when it's an angle? We're going to have to inverse at the end. So let's work. Let's see if we can all match. Okay, number 3. Do you find any pairs? Do you have a SAS, a triple S? Yeah, I have a pair. I see a pair. So sine law is my answer. Oh, this isn't good. What I want to find, I don't have info on that. I can't pair it with anything, right? There's nothing there. That's not good. So I can't do that. But what could I use? I have this 25 down there. So what's the 25 going to help me with? 25 will help me to get the top angle. Okay? So let's do that and then see where to go. So I'm going to go these 2 pairs first. Okay, I'm going to get that top angle. So 27 over sine 68 and 25 across sine. I'm going to go with a y just to call it something. Okay, get me that angle to 1 decimal. Okay, so 59.1 degrees. Hopefully you're matching. That's good. Okay, what I'm actually going to do is I'm just going to place it in there to help us see what's going on. Now, does anybody know what I have to do on my next step in this triangle?
180 subtract 2 angles.
180 subtract the other angles gives me the last corner is 52.9 because I did the 180 rule, right? Okay. Now I'm going to do another pair. I got to do this again. I'm going to go with this and this. So my orange pairs is the last step. I'm going to call it X. So there's the setup. And again, figure out what do you have to multiply and divide. There should be no inversing on the last one there because it is a side length. You should not have to inverse it. And then on the side lengths, I'm going to go to 2 decimal places. Number 4, what is the situation? Do we have pairs, SAS, triple S? That's always the first question. So I have triple S. So that means, which formula would that be? The last formula. So the last formula. Okay. This says to find the largest angle. Well, which one is that? How do I know which angle would have to be the largest one? It would have to be located across from the largest side. So we're going to find Z. So cos of Z equals, and I'm going to draw this fraction bar, because the formula has a fraction bar like that. What number has to go in the subtract spot? That's what I always do first. Which value goes in the last part of the formula? Subtract 9 squared. Always the opposite one you have to subtract. And then 6 squared and 8 squared. Okay, so did you notice how I filled this part in first? And then that helped me just understand 6 and 8 go. So this one is a brackets. So make sure that's what you're typing on your calculator. The brackets divided by brackets. You got to put that in brackets. And it's an angle, so cos inverse, and go to 1 decimal. Okay, 78.6. Sounds good. Okay, so this is a page on your test where you have to figure out how many triangles Okay, so I'm looking for understanding the opposite side. So A is the opposite side of A. What do you know? A is bigger. So what does that already just tell me? 1 triangle. Okay? That one's nice. You don't have to do any work with it. If the opposite side is longer, then that's it. Okay, opposite is 3. Okay, that's shorter. So we're going to have to figure it out. So right beside A is side B, which is 8. And we're going to figure out how does the 3 fit into all this when it's across from it. Okay, so let's get the imaginary height number. And And then also with a height comes a 90-degree angle, right? Okay, so times divide. FYI, if you really want to cheat, sine of 90 is 1, so I don't even use it because it's 1. Okay, 5.95. What does that tell you about the height of 3? What's it going to do in this situation?
Is it sine of 48 or sine of 48?
42. That should be 42. Thank you. So did you have a different number than that?
Yeah, I got 5.35.
5.35. Thank you. I just did a copy error. Whoops. Thanks for catching me. 5.35. Okay. So what does that tell me about the 3? How is it going to fit into this context of the triangle? It's going to be too short. It's not going to reach because the height, that is the smallest you could be to hit that line. So there's no triangles. Okay, C. The opposite side. Well, that one is shorter. So we're going to have to figure it out. So there's my angle of 34. Beside it is 3. I'm going to figure out how does the opposite side of 2, how does it fit into this? Okay, so let's get the height. So 3 over sine 90 equals height over sine 34. So I was getting a 1.68. Does that work? So where does the 2 fit into that situation? It would be longer than that, but shorter than that. So it'd be in between, which will make 2 triangles. Okay? So when it's in between the height and the other side, it will end up being 2 triangles. Okay, the next, this is obtuse. So now, really, our rules just don't apply right now. Obtuse triangles are just a different situation. So if I have a 120-degree angle, beside it is 10. All I want to know is, will 25 reach? Will it reach? Okay, so I'm going to just do the sine law, and if it would give me an error, it's telling me that 25 is not going to reach it. So 25 over sine 120, 10 over sine b. And when we do the inverse, we're either thinking about, did it give me something or an error? That's what we're trying to just figure out. Is it going to be reaching or not reaching? So that's the obtuse situation. And I got a number, so it would be long enough. But there's only one triangle there's no way to even make two triangles with an obtuse, because you can't have another obtuse angle in that side. Okay. Solve for the two option triangle from above. So that was question C. So question C. Oh, I skipped E. What? I'm just falling apart here. Sorry. Thank you. E. A is 36.8698 degrees. B is 10. Sorry, I guess I should have started with the opposite side was shorter. Opposite side was shorter, that's why I just jumped into this. How is 6 going to fit? How is 6 going to fit? That means I need to analyze what the height is to see where that is going to fit. So 10 over sine 90 is that pair. And height over sine of that angle, I'm going to take all those decimals. I got 6 on that height. And the opposite side is 6. So where is that opposite side going to fit? That opposite side is going to fit exactly there and only touch exactly once. So you're going to have exactly a right triangle on that one. And that's it. Okay? Because there can't be a way for one angle to be 90 and then to have a second triangle that's 90. That is the same triangle. Okay, now this number 6 says solve for the triangle that had 2. So this is the one that we picked that had 2. Number 5C. So the side lengths were 2, 3, and the angle was 34. Okay, I'm going to color code, and while you're writing the test, if you want to borrow some of my highlighters, just call me over and we can do that. So here's the one triangle, 3, 2, and question mark. That's the one thing I will figure out, 3, 2, and the third side. And the other one, I will get that for you. So 3, 2, and question mark. So 3, 2, and question mark. Okay, that's our goal. Okay, remember your triangles, 3, 2, and the third side. Okay, so here we go. Sine law pair, we have the 2 and the 34. So 2 over sine 34 equals 3 across sine B. Now don't forget, because we're having two triangles, everything has two options. So can you get me times, divide, inverse? But then on that, you're telling me the angle could be this or that. How did I get the or part of it? Do you remember how I got what the other option was? It's the supplementary. So whatever, subtract from 180, right? Okay, those are always your two options, the supplementary options. So if one was 40, the other one would have been 140. If you had a 20 degree, the other one would have been 160. Okay. That is across from the side 3. So where, there or there? So across from the 3 in the pink, across from the 3 in the yellow. Do you understand where to put the small angle and the big angle because of the drawing?
Yes.
So the small angle, the big angle. Okay, one is always less than 90, one is always bigger than 90. Acute, obtuse. Okay, now I'm going to find the other angle. So in the pink triangle, you'd get that angle, and in the yellow triangle, you would get that angle. So you give me the last 180 minus Okay, so you're looking, again, these colors are really nice because you can see the last angle in my pink triangle, the last angle in my yellow triangle. And then you have one more thing to do. Okay, so in the pink triangle, we're going to go 2 with sine 34 as a pair. 2 sine 34, and then we're going to call it side C is now across from 23 degrees. Okay, I'm just going to write the other one down. You can figure that out. And then the other one in the yellow triangle, you have 2 and 34. You can do that again. And now you're across from 89 degrees on the top there. So can you get me the two side lengths by timesing and dividing?